Hi, I'll be doing an explanation for these two questions on integration and differentiation. So let's begin with question 1. Question 1 is an integration question, and here are the information that we can pick up from this question, which is shown in this slide. In this question, we cannot integrate this equation given immediately, hence we will need to convert this equation into the form of partial fractions so that we can start integrating. So after I've converted it into partial fractions and integrate it, we will get a unknown c, which is a constant value, and it could be any value. So in order to find this constant c value, we have to substitute x equals to 1, t equals to 0 into the equation to find the constant c. So after finding the value of constant c, we can now rewrite the value of constant c in the equation to make the equation complete. Then we can find the number of days later. So the question is asking for the number of days for 50% of the community to be infected by this virus. So the community has 250 people, so 50% will be 250 times 50% equals to 125. So we sub x equals 125 people into the equation, and we will get 14.4968, which is 4 decimal places. However, the number of days required must be a whole number, so we'll round it up to 15 days. And that will be the final answer for question 1. Next is question 2. In this question, we need here are the information that we can pick up from this question before we can start working out the steps. So we are given two formulas represented by c for each drug A and B. In order to obtain dc over dx, we have to differentiate c for both drug A and B. So let's start differentiating for drug A first. We'll get the differentiate of c for drug A by product rule, and after obtaining the expression for dc over dx, we will substitute x equals to 6 so that we can find the value of dc over dx when x equals to 6, and we'll get minus 93,600. So we need to find dc over dt, which is the rate of cancer cells that's being destroyed per minute. So we'll multiply dc over dx and dx over dt to obtain it, and we'll get minus 936 for dc over dt drug A. For drug B, we'll have to differentiate the equation of C2, and we'll differentiate it by product rule and addition subtraction rule. So we have to break this equation into 2 and differentiate minus 30x ln at bracket x plus 1 for the product rule, and the remaining will be by addition subtraction rule. So once the expression of dc over dx is formed for drug B, we can start subbing in the values x equals to 6 into the equation of dc over dx, and so that we can find the value of dc over dx when x equals to 6. And similarly, as what we did earlier on, we will have to find dc over dt, hence we have to multiply dc over dx and dx over dt, and we will get minus 7.68 for drug B. There's one thing I would like to highlight, which is that we are getting negative values in our workings. The reason for it is because this is the rate of decrease for the cancer cells. Their variable are decreasing because they are being destroyed in respect to time. So we will expect the dc over dt to be a negative value. And lastly, I would like to end off with the conclusion, which is I would choose drug A over drug B to answer this question, because drug A destroys more cancer cells than drug B per minute, and hence it's more effective. Okay, that's all for these two questions. Thank you very much.